Welcome to Space Channel. At here we have all about space and galaxy. Thank for your watching video. Now we'll find out our home planet. Yep, it is Earth. Earth is the third planet from the Sun and the fifth largest in the solar system. Just slightly larger than nearby Venus, Earth is the biggest of the terrestrial planets. The name Earth is at least 1,000 years old. All of the planets, except for Earth, were named after Greek and Roman gods and goddesses. However, the name Earth is an English-German word, which simply means the ground. With a radius of 3,959 miles, 6,371 kilometers, Earth is the biggest of the terrestrial planets and the fifth largest planet overall. From an average distance of 93 million miles, 150 million kilometers, Earth is exactly 1 astronomical unit away from the Sun, because 1 astronomical unit, abbreviated as AU, is the distance from the Sun to Earth. This unit provides an easy way to quickly compare planets' distances from the Sun. It takes about 8 minutes for light from the Sun to reach our planet. As Earth orbits the Sun, it completes 1 rotation every 23. To keep our yearly calendars consistent with our orbit around the Sun, every 4 years we add 1 day. That day is called a leap day, and the year it's added to is called a leap year. Earth's axis of rotation is tilted 23. Four degrees with respect to the plane of Earth's orbit around the Sun. This tilt causes our yearly cycle of seasons. During part of the year, the northern hemisphere is tilted toward the Sun, and the southern hemisphere is tilted away. With the Sun higher in the sky, solar heating is greater in the north, producing summer there. When spring and fall begin, both hemispheres receive roughly equal amounts of heat from the Sun. When the solar system settled into its current layout about 4.5 billion years ago, Earth formed when gravity pulled swirling gas and dust in to become the third planet from the Sun. Like its fellow terrestrial planets, Earth has a central core, a rocky mantle and a solid crust. Earth is composed of 4 main layers, starting with an inner core at the planet center, enveloped by the outer core, mantle and crust. There the temperature is as high as 9,800 degrees Fahrenheit, 5,400 degrees Celsius. Surrounding the inner core is the outer core. This layer is about 1,400 miles (2,300 kilometers) thick, made of iron and nickel fluids. In between the outer core and crust is the mantle, the thickest layer. This hot, viscous mixture of molten rock is about 1,800 miles (2,900 kilometers) thick and has the consistency of caramel. The outermost layer, Earth's crust, goes about 19 miles (30 kilometers) deep on average on land. At the bottom of the ocean, the crust is thinner and extends about 3 miles (5 kilometers) from the sea floor to the top of the mantle. Like Mars and Venus, Earth has volcanoes, mountains, and valleys. Earth's lithosphere, which includes the crust, both continental and oceanic, and the upper mantle, is divided into huge plates that are constantly moving. For example, the North American plate moves west over the Pacific Ocean basin, roughly at a rate equal to the growth of our fingernails. Earthquakes result when plates grind past one another, right up over one another, collide to make mountains, or split and separate. Earth's global ocean, which covers nearly 70% of the planet's surface, has an average depth of about 2.5 miles (4 kilometers) and contains 97% of Earth's water. Almost all of Earth's volcanoes are hidden under these oceans. Hawaii's Mauna Kea volcano is taller from base to summit than Mount Everest, but most of it is underwater. Earth's longest mountain range is also underwater, at the bottom of the Arctic and Atlantic Oceans. It is 4 times longer than the Andes, Rockies, and Himalayas combined. Near the surface, Earth has an atmosphere that consists of 78% nitrogen, 21% oxygen, and 1% other gases such as argon, carbon dioxide and neon. The atmosphere affects Earth's long-term climate and short-term local weather, and shields us from much of the harmful radiation coming from the sun. It also protects us from meteoroids, most of which burn up in the atmosphere, seen as meteors in the night sky, before they can strike the surface as meteorites. Earth has a very hospitable temperature and mix of chemicals that have made life possible here. Most notably, Earth is unique in that most of our planet is covered in water, since the temperature allows liquid water to exist for extended periods of time. Some of the features of our planet that make it great for sustaining life are changing due to the ongoing effects of climate change. To find out more, visit our sister website, climate.nasa.gov. Earth is the only planet that has a single moon. Our moon is the brightest and most familiar object in the night sky. In many ways, the moon is responsible for making Earth such a great home. It stabilizes our planet's wobble, which has made the climate less variable over thousands of years. When Earth was a young planet, a large chunk of rock smashed into it, displacing a portion of Earth's interior. The resulting chunks clumped together and formed our moon. With a radius of 1,080 miles, 1,738 kilometers, the moon is the fifth largest moon in our solar system, after Ganymede, Titan, Callisto, and Io. That means 30 Earth-sized planets could fit in between Earth and the moon. Our planet's rapid rotation and molten nickel-iron core give rise to a magnetic field, which the solar wind distorts into a teardrop shape in space. The solar wind is a stream of charged particles continuously ejected from the sun. When charged particles from the solar wind become trapped in Earth's magnetic field, they collide with air molecules above our planet's magnetic poles. The magnetic field is what causes compass needles to point to the North Pole regardless of which way you turn. But the magnetic polarity of Earth can change, flipping the direction of the magnetic field. The geologic record tells scientists that a magnetic reversal takes place about every 400,000 years on average, but the timing is very irregular. But when it does happen, compass needles are likely to point in many different directions for a few centuries while the switch is being made. And after the switch is completed, they will all point south instead of north. Earth is made up of complex, interactive systems that create a constantly changing world that we are striving to understand. Thanks for your watching again. Please like, subscribe to watch more videos, and let your feedback at comment below. Thanks.